Imagine a single file sitting in an S3 bucket, maybe a customer invoice, maybe a private key. Someone or something asks AWS to open that door and read the object. Here's the puzzle. How does AWS decide whether to unlock it without handing every developer, every server, and every script a permanent master key? Being on AWS is not enough. A stolen password, a leaked access key, malware on a laptop, those are exactly the threats identity systems exist to contain. By the end of this walkthrough, you should see why the question is never just, are you connected? But three sharper ones. Who is asking? What exact action do they want? And on which resource? That is the job of IAM, Identity and Access Management. IAM answers two different questions, and mixing them up is the first big misconception. Authentication asks, who are you? It is the reception desk check, password, access key, and often a second factor. Multi-factor authentication, or EMEFAY, is not a permission. It is an extra proof that the person holding the password is really the person you expect. Authorization asks a different question. What are you allowed to do? Signing in successfully does not open every door in the building. You can be a verified employee and still be blocked from the vault. Hold that distinction. Authentication proves identity. Authorization evaluates permission. Login is not a blank check. Every AWS account starts with one special identity, the root user. It has unrestricted access to every service and to billing. Treat it like the master key to the whole building. Lock it away, enable MFA on it, and never use it for daily work. Reserve it for a handful of account-level emergencies. For everything else, IAM gives you four pieces that solve different management problems. Users are long-term identities for people or applications. They carry permanent credentials like passwords and access keys. Groups are not identities at all. They have no credentials. A group is a container so you can attach permissions once and every member inherits them. Roles are temporary identities assumed by a trusted entity. No long-lived password, credentials that rotate automatically. And policies are the written rules, JSON documents that say what actions are allowed or denied on which resources. One building, four tools. Each answers a different "how do we manage this safely" question. Let us put the four components side by side, because this is where people get tangled. An IAM user represents a specific person or application with long-term credentials, a password for the console, access keys for the API. You rarely give humans wild direct access forever. You still create the user, then manage them carefully. An IAM group is a logical container. It has no credentials and is not an identity. Its job is boring and powerful. Assign common permissions once, say read-only billing or developer power on a staging account, and every user you drop into the group inherits them. Fewer one-off mistakes, better scalability. An IAM role is a temporary identity assumed by a trusted entity for a specific task. Credentials are temporary and automatically rotated. That is why roles win for AWS services talking to each other and for short, elevated human tasks. Policies define permissions. They have no credentials of their own. They attach to users, groups, or roles, or hang on a resource. If you remember only one row of the table, users hold permanent keys, groups hold none, roles hold temporary keys, policies hold the rules. Watch how the pieces fit a real team. You create IAM users for people who need ongoing access, console, command line, or API. Best practice is not to attach policies to each user one by one. Put developers in a developers group, attach the shared permissions to the group, and every new hire inherits the same floor plan. Here's a misconception to kill early. A group is not a login. Nobody signs in as the developers group. The group only organizes permissions, now roles. When an EC2 instance needs to read from S3, you do not bake a permanent access key into the machine image. That key would sit on disk forever. a gift to anyone who steals a snapshot. Instead, the instance assumes a role. AWS hands it temporary credentials that expire and rotate. Same idea for cross account access. Trust a role, assume it for a task, drop it when the task ends. Users for long term people, groups for shared human permissions, roles for temporary, often automated access. Policies define the rules those identities carry. A permission is not a feeling of trust, it is a precise statement. IAM policies are JSON documents, and each statement is built from a few fields you can watch assemble. First, effect, either allow or deny, that is the verb of the rule. Next, action, the API operation like S3 get object or S3 list bucket. Then resource, which bucket, which object, which database. Optionally, condition, maybe only from a certain IP range, only during business hours, only if MFA was used. Picture a badge that says allow get object on this one invoice prefix and only if MFA is present. That is a policy. AWS managed policies cover common jobs. Customer managed policies are ones you write for your org. Inline policies stick to a single user, group, or role. Resource-based policies hang on the resource itself. An S3 bucket policy is the classic example. Plain language, a permission names an effect, an action, and a resource, nothing fuzzier. Work a concrete request. Suppose a developer wants S3 get object on ARN AWS S3 invoices star. Their group policy allows get object on that prefix. Looks good, but wait. Add a condition. The request must come from the corporate IP range. Add another. Multi-factor authentication must be present in the session. Now a stolen laptop on a cafe Wi-Fi fails the IP check. A password phished without the second factor fails the MFA check. The effect is still allow, the action and resource still match, and yet the gate stays closed because conditions failed. That is the difference between a vague sense of trust and a policy. Time windows work the same way. Allow a maintenance role only during a change window. Deny deletes on production buckets for everyone except a break glass role. When you write policies, read them out loud. Who may do what, on which thing, under what extra constraints. If you cannot finish that sentence, the policy is not done. Now the request hits the decision gate. Watch the workflow. First, identify who is asking, a user, a role session, a federated identity. Second, authenticate them. Third, gather every applicable policy, identity policies, resource policies, permissions boundaries, if any. Fourth, evaluate. Fifth, either grant the action on the resource or refuse it. Here's the logical punchline, and it surprises people. An explicit deny always wins. If any policy says deny for that action on that resource, the door stays shut, even if 10 other policies say allow. An explicit allow grants access only when no deny overrides it. And if there is no explicit allow at all, the answer is still no. That is implicit deny. Default is locked. So I don't see a deny is not permission. Absence of deny is not allow. You need a clear allow and zero denies in the path. That single rule is how IAM stays safe by default. 3 quick scenarios so the evaluation rule sticks. Scenario 1, a user has an allow on S3 list bucket from a group policy and a deny on that same action from a permissions boundary or an explicit deny statement. Result, denied. Explicit deny always wins. Scenario 2, a user has allow on get object for a bucket and no deny anywhere. Result, allowed. The object door opens. Scenario 3, a brand new IAM user with no policies attached tries to read anything. There is no deny statement written down. Result, still denied. Implicit deny. Default closed. This is why least privilege is natural in IAM. You do not start open and carve out denials. You start closed and cut precise allows. When something breaks in production with an access denied error, your debugging question is not who denied me first, It is where is my allow and is any deny overriding it? Hold that mental model, it will save you hours. Return to the EC2 instance that needs one object from S3. The insecure path stores a long-term access key on the instance. The secure path attaches a role. The instance assumes that role, receives temporary credentials, reads the object, and those credentials expire. No permanent key to leak from a disk image. That pattern pairs with least privilege, the design goal of the whole system. Start with no permissions, add only what the task requires. If the job is get object on one prefix, do not grant full bucket admin. If the job is list, grant list bucket, not delete. Least privilege does not mean deny everything forever. It means the smallest sufficient set. Groups and role-based access control help you scale that idea. Permissions follow the job function, not a one-off exception for each person. Federation and single sign-on let people prove identity through your company directory instead of yet another password. MFA hardens the humans who still hold long-term credentials. Temporary passes for machines. Minimal doors unlocked for each task. That is how you avoid the master key problem we opened with. As the organization grows, you stop minting long-term IAM users for every human. Federation lets people sign in with an external identity provider, your company directory, and receive AWS access through roles. Single sign-on reduces password fatigue and means offboarding is one disable in the directory, not a scavenger hunt across access keys. Role-based access control assigns permissions by job function. Billing readers, platform admins, data scientists. You map those jobs to groups or to roles, not to 50 bespoke user policies. That alignment with org structure cuts excess privilege. The quiet risk where someone still has yesterday's project admin rights. None of this replaces the gate logic. Federation still authenticates. RBAC still attaches policies. MFA still hardens sign-in. They are scaling tools on top of the same identity, policy, and evaluate loop. So when you hear we use SSO and RBAC, translate it. Humans prove who they are through the company IDP, assume a role that matches their job, and that role carries the least privilege policy bundle. Putting it into practice follows a simple sequence. Create an IAM user for a person who needs access. Choose console or programmatic access as needed. Create a group, add users to it, and attach policies to the group rather than scattering them on individuals. Enable MFA for anyone with real power, and always for the root user. Create roles when an AWS service or another account must act. EC2 to S3, Lambda to DynamoDB, cross-account read. Lock away root credentials. Prefer groups over direct user policies. Prefer roles over embedding keys in applications. Rotate credentials on a schedule so a leaked key has a short life. The benefits stack up. Centralized control of who can do what, fine-grained policies down to a single action on a single resource, least privilege as the default posture, and a model that still scales as the team and the account grow. Related ideas you will meet beside IAM include single sign-on, multi-factor authentication, role-based access control, and privileged access management, all circling the same goal. Verify the actor, limit the action. Zoom out, IAM is how AWS decides who may touch a resource and what exact action they may take. It authenticates the requester, evaluates precise policies, and grants access only when an allow is present and no deny overrides it. Roles replace long-lived keys for services. Least privilege keeps every unlocked door intentional. In the broader field, this is access control with a zero trust flavor. Do not trust someone because they are inside the network or already logged in. Verify the identity and the exact action on the exact resource. One open question to take with you. What would change if that same S3 request came from another AWS account at 2 in the morning or from a session that never completed MFA? The same building, the same gates, and the policy language is expressive enough to answer each of those cleanly. That is the power of getting the model right.